before I even start talking about this, let me just say math is basically another language. It's like learning a foreign language because the first thing, like symbols in math mean things just like words in another language, and you have to mentally translate between them. And that turns out to be not trivial at all. The actual math involved in solving most of these equations is going to be very, very simple. But that doesn't mean they're easy, as you guys are probably aware. And it's often hard to identify where the tricky part is. Well, this is the tricky part. Turning your English phrase into an equation or an expression. And we'll talk about the difference between equations and expressions in just a second. But first, let me share up my screen. Actually, let me get a whiteboard going. Oh, that's actually not the first thing I wanted to share. The first thing I wanted to share is this thing. Yeah, this guy right here, where I've typed a few things to look out for. So there are a few keywords and phrases to look for. There's one that I have not listed on here because it's not in operation, which we will talk about in just a second. It is by far the most important one. But just addition, subtraction, multiplication, division. I'll scroll through this a little bit so you can see it. Addition, together, combined, more than, added, sum, total of, etc. And then subtraction, difference, less than, minus. I want to point out two of these, more than and less than. Yeah, this is what I want my whiteboard for. So there's actually two really big, this is a very easy to misidentify. If I say 3 more than X, what I'm really saying is I want the number that's 3 more than X, right? So that would be X plus 3. Or if I say, let me use an actual number, right? So 2 less than 7. That's saying that I want the number that's two units to the left of 7 on a number line, or just 2 less than 7, right? That's 5, right? That's 7 minus 2, which is 5, obviously, right? 5 is the number that is 2 less than 7. That's a big difference than saying this: 3 is more than X. That says that 3 is greater than X. And that is wildly different, right? So for one thing, this thing up here is not a complete sentence. And this is, because the word is a verb. I don't know how much into grammar you guys are, but I'm a little bit of a grammar nerd. This is not a complete sentence. This is just a phrase. This is a complete sentence because it's got a verb in it and subject and predicate, right? And similarly, if I said 2 is less than 7, that's the same thing as saying that 2 is less than 7, right? A true statement, but not asking for the number that is 2 less than 7. So those are things that you have to watch out for. This is super easy to get tripped up on. My students get tripped up on this all the time. So if this happens to you and makes you feel dumb, don't feel dumb. This is a super common mistake. So yeah, watch out for that, but we'll revisit those in a little bit. All right, let me go back to my list. Okay, so there's a few of these. I'll let you scroll through these, or I'll let you, pause the video and go through these. I'll scroll them through them a little bit slow here. Multiplication. The one that we learned about in percentages and fractions that is used a lot is of. That's mostly used in reference to percentages and fractions, like half of something. Half of 6 is 3, right? Because we're going to take a half times 6. And then for multiplication, other than that, it's mostly pretty straightforward. Times, product, or multiplied by are usually the phrases you're looking for. However, I will point out that there's very often an unstated assumption that you will know geometry formulas. And most of the area formulas have some amount of multiplication. You almost have to with area formulas. So base times height, 1/2 base times height, length times width, pi r squared, all those things that end up involving multiplication. So watch out for lots of multiplication in geometry problems too. And then division, there are 3 of these: quotient, ratio, and per. There's some others that you can use here. I think the one that occurs most often, or at least is most subtle, is per. right? And so like if I say I'm going 5 miles per hour, the way you would write that is you're thinking of going 5 miles divided by 1 hour is your speed. So anytime you hear per, there's some division in there somewhere. Well, I don't know if I have any examples of that coming up, but you'll see plenty of those in any set of word problems. Quotient and ratio both mean divide, right? Like the quotient of A and B is A over B. The ratio of A and B is A over B. Yeah, and certainly there are others as well. Like English can be really complicated, and you can say things in a lot of kind of funny ways, and sometimes math books do. So you have to be on the lookout for different words that can be used. But I try to get most of them here. Like you have to get a pretty tortured sentence to use ones that I didn't use here. So let me just briefly scroll through those again. There you go. So you can pause the video there somewhere. And actually, you know what? Let me do this. Can I get them all on the same screen? Probably. One more try. Okay. I hope. Yeah, there you go. You can pause and use that if you want. Okay. So I've got 4 word problems here, sort of. I've got each one is a set of 2. And so the difference between an expression and an equation is that an expression is not a thing you can solve. It's just it's like a phrase, right? So for instance, let's go back to our whiteboard for a second and say that this right here, x plus 3, that is an expression. That's not solvable. It does not mean, by the way, that x is negative 3. It just means that I'm looking for whatever number is 3 more than x, and I don't know what x is, right? So x could be anything. So if x was 10, this would be 13. If x was 105, this would be 108, right? But this is not solvable. It's not, you can't tell whether this is true or false. It doesn't have a true or false value. It's just the value of some number. This is an expression. Something that's an equation has an equal sign somewhere in it. So for instance, if I said 3 more than x is 10, this says that this expression, 3 more than x, is 10. And this right here is the most important keyword that there is in all of math. The word is. Is means equals. You can combine it with other things to mean other things that are similar to equals. For instance, whoops, did I not? The heck? Whatever. What? I don't know why it's doing this. Anyway, like 3 is more than x. Well, this inequality, it serves very much the same function as equals. It means something different, but it basically separates your 2 things into separate sides, right? And we'll learn how to solve inequalities soon enough, and it's pretty much just like equations. Hello? There we go. So this is an equation. It is a complete sentence, and it's solvable, right? Now I can find x, right? You can just tell by inspection. Like we could do some algebra, right? Subtract 3 from both sides, that'll give you 7. But 3, you can also just think about this one, right? 3 more than some number is 10. Well, what's the number that if I added 3 to it would give me 10? It's 7. Right? So equations have to be complete sentences, and they virtually always involve the word is. I struggle to think of a sentence that could be an equation without using is. So the very first thing I always look for in any word problem that I'm doing is the word is. I try and find is, and that tells me like things to the left of is go on one side of the equation and things to the right of is go on the other side. So when you are looking at some huge equation or some huge paragraph, right, that's a word problem, and it's very intimidating, look for the is. Try to find the is in some sentence, and that's the sentence with the equation in it, and one side before the is one side of the equation, after is the other side. So that breaks your word problem into more bite-sized problems, right? You're not trying to choke on the whole thing at once. You can get a little bite at a time if you just break it into two pieces, one before is and one after is. So that is my number one tip for doing word problems, is when you are reading it and it looks all confusing, try to find the word is, use that to split your word problem into two pieces, and then before is one side, after is the other. And maybe you'll be able to like simplify if you do some stuff before and after the is. Don't even do that on the first pass through a problem. Just write it down. Just is equals, left side means something, right side means something else, and try to get your equations that way. Okay. Let's look at, I stole these from another book. So I'm going to do them two at a time, because the first thing I've done in each case is an expression, and the second thing is an equation. And I want to highlight the differences between those because they're really important. So the sum of a number and negative 11, right? So that is not a sentence. There's no verb in that. There's no verb in that. It's just a phrase. I suppose I've made it look like a sentence by putting a period after it. I suppose I probably shouldn't have. Sum, right? So that is telling me addition. A number, I want to think of that as my variable. You can use whatever letter you want. I tend to use X most of the time. I think most other people do. And negative 11, that's another number. So let's look at this. Go back here. So number one, the sum of a number. So the sum of a number and negative 11. So the two things with the and are the things that you're adding, right? The sum of a number and negative 11. You can write this as x plus negative 11 if you want. You can also write it as x minus 11, which is how I would do it after I simplified it a little bit. Oh, sorry. Let me do this differently, because that makes it look like this is an equation. What I really mean is this. I can simplify this to be x minus 11. Yeah, that's it. This is an expression. It is not an equation. That is not solvable. On the other hand, this, the sum of a number and negative 11, is negative 15. And then I have another sentence saying find the number, right? So what I'm looking for here is I see the word is. That tells me that I have two expressions on either side of the is. On the left side, I have the sum of a number and negative 11, which I know is x minus 11. And on the right side, I have another expression that just says negative 15. So a number is an expression. It's a very simple one, but it is one. And so that tells me, so I'm going to start with an equal sign here. On the left side of it, I'm going to put my expression that I got there, and on the right side, I'm going to put the other thing. Right? So for 2, what I'm going to do is I'm going to start like this, equals. Now my left side was the sum of x and negative 11, which we've already determined is x minus 11. And then the right side was negative 15. Then we can solve that. Right, add 11 to both sides, x is negative 4. But I'm not going to worry about that for right now. Right now, I'm just trying to write them down. And this is what I mean by the math required to solve the equations is usually very simple. Like if you can get to the point where you're writing down the equation, you're pretty much home free. So all of your effort should be spent making sure you can get to this point, because the rest of it is free, right? I'm confident that everybody in this class can solve that equation, no trouble. So don't worry about trying, like very often what people will end up doing is they will try and get to the solution right away. And that's not where you want to get to, because obviously this one's relatively easy, but they clearly get harder. So what you want to do is make sure that you can get to the equation and then do some algebra, which is usually very simple. So don't worry about getting to the solution from the start. Worry about getting to the equation from the start, and then from the equation, then you can get to the solution. But it's getting this far that's usually the hard part. So let's do another one. Flip back to here. All right. 40 less than 5 times a number. Now, here's one of those tricky ones that I wanted to point out, which is the less than. So I got 40 less than 5 times a number is the thing that I'm going to try and write down. So 40 less than 5 times a number makes it seem like you might want to do this. But that is wrong. And it's wrong because subtraction is backwards in English. And it's the only one of the 4 operations that is, which is a little annoying. So this is not what you want. So think about it this way. Let me go back to page 1. When I said 2 less than 7, I didn't do 2 minus 7, I did 7 minus 2, because subtraction is backwards in English. So if I say 2 less than 7, what I'm looking for is the number that is 2 fewer than 7, right? So that means that I start at 7 and then go 2 backward to get 5. And that's the most common way to write. That's the most common way that subtraction is used in word problems. So sorry, that's just the way it is. Subtraction's backwards. When you see less than, don't do it in the order it appears. Do it in the other order. So for the thing that I was pointing out here, 40 less than 5 times a number. Well, 5 times a number is pretty clearly 5x. I hope that's obvious, right? A number, there's your x, times 5x. And then 40 less than that. So I'm starting with 5x and then subtracting off 40. So that means that the thing that I want looks like this. 5x minus 40. My black 5x minus 40. Got kind of a tall 5 there. Pardon the handwriting. It'll get worse. So this is the expression that I want. And notice 40 less than 5 times a number is not a complete sentence. That is just a phrase. Consequently, it is not an equation, it is just an expression, right? So this is an expression, not a complete equation. Number 4, I don't remember what the rest of this was. 40 less than 5 times a number is 52 less than the number. So 52 less than the number is another expression. And that's what an equation is it's 2 expressions with an equal sign in the middle. So the left side of my equation is this expression, and the right side of my equation is this expression, and the middle is the equal sign. So that's how you want to separate these out, right? Look for the is, find the expression on the left, find the expression on the right, build your equation. So 52 less than the number, well, my number was called x, so this would be x minus 52, and again, subtraction's backwards. So what I have there is 5x minus 40 is x minus, that's a terrible x minus 52. Right, then we could solve that. Add 40 to both sides, subtract the x, divide by 4, and you get an answer. This is one where you probably can't just do that in your head. Even I struggle a little bit to do that in my head. And so this is what I mean by don't try to see the answer from the very beginning. You're not going to be able to figure it out, right? Like that's too complicated to do in your head easily. However, once we get the equation down, this is a very simple equation to solve. I hope everybody can solve this one. If you can't, don't worry. We'll actually practice this in the next section, 2 sections from now. I don't remember the exact section we're going to be doing it in, but this is not a hard thing to solve. And if you can't solve this right now, you will be able to very soon. But yeah, this is an equation. It was a complete sentence. In fact, it was 2 sentences. And there was an is in it that told me where the equals goes. All right, let's do something that's not quite so, I need a new one of these. Let's do something that's not quite so simple. We'll do an actual word problem or an actual like story problem. So here's the problem we eventually want to set up, right? A carpenter cuts a 6-foot board into 2 pieces. One piece is 3 times as long as the other. Find the length of each piece. This thing right here, once I've read the first sentence, before I even read any of the rest of it, I want to draw a picture. Carpenter cuts a 6-foot board into 2 pieces. Notice it doesn't say they're equal pieces, just 2 pieces. So before I do anything else, before I even read the rest of the problem, I want to draw a picture, because humans are visual learners. Most people take in most of their information visually, and so having a visual aid is really, really helpful. It will make your problems significantly easier. A lot of my students have asked me in the past, do I have to draw a picture? Which is the wrong question. The question should be, do I get to draw a picture? And hopefully the answer is yes, because that'll make things easier. I have a 6-foot board that I want to cut into 2 pieces. So I'm going to draw a line. We could draw a nice little board, but I'm not going to bother. I'm just going to say this thing is 6. And we're cutting it into 2 pieces. I'm specifically going to make them not look equal, because it doesn't say 2 equal pieces. So I don't want to make my picture make me think that they are equal. I'm going to make one a little bit bigger than the other. And then before I do anything else, I can actually get some variables in here. I've got this thing that I know this is 6. And then more importantly, I have 2 things that I don't know, right? I don't know how long this is, and I don't know how long that is. So I want to make expressions for them. So the easiest thing to do is just pick one of them to be x. I'm going to make this one x. And so now you want to think, if this is x over here, right, this distance right here is x, how far is this one? Right? How big is question mark there? Well, I know that x plus whatever this is has to be 6. So I need some way to think of whatever the rest of 6 is, essentially. Now, I don't know what that is for right now, so I'm just going to call it y for a second. We're actually going to come up with a different and better name for it in just a second. But I know that x plus y is 6. Right? The length of x plus the length of y has to be 6 feet, because the board was 6 feet. And so here's a thing you can do. I think most of you probably already know how to do this. But what I'm going to do is I want to know what y is, right? So I've got a question mark here. So I'm going to solve for it. I'm just going to subtract x from both sides. And you might say to yourself, well, how do you subtract x from 6? Like this. You just write it as 6 minus x. Right? And another way to think of this is, let's pick some numbers for x, right? These are not the numbers we're actually going to use in the problem, just sort of to help us understand how big this is. Like, let's say x is 1. If x is 1, then y has to be 5, right? Because it's the rest of 6. If I do 6 minus 1, I get 5. What if x was 4? Well, then y would be 2, right? It wouldn't fit my picture very well, but let's say x is 4. And then that leaves 2 feet left over. So I would have y is 6 minus 4, which is 2. Right? So I don't want to call this thing y, because when you have 2 variables, things get a lot more complicated. What I really want to do is call it 6 minus x. Like, that's the thing that I want. So that's what I'm going to call it. So this guy is 6 minus x. Now, let me point out, the only thing I have used from the problem is where it said a carpenter cuts a 6-foot board into 2 pieces, right? This is the most general version of cutting something into 2 pieces that you can do, right? I don't know how long the 2 pieces are. One of them we're going to call x, and the other one we're going to base on that x. And so it's 6 minus x. All right. So I haven't even done anything, or I haven't even, like, all it says is a carpenter cuts a 6-foot board into 2 pieces, right? I haven't looked at any information about the 2 pieces. I don't know what they're looking for. I don't know any relationship yet. Of course, that's in the next sentence, right? One piece is 3 times as long as the other. Find the length of each piece. All right, so you might ask yourself, how do we turn this into something we can use? Well, the first thing we do is we look for is, right? This is telling me one piece, that's going to be one side of the equation, 3 times as long as the other piece is the other side, the other equation, or the other side of the equation. And then find the length of each piece. So this says that my 2 pieces the bigger one is 3 times as big as the smaller one. Now, this brings up a good point here. It's very easy to think that that means this 3 multiplies by the bigger one gives you the smaller one, but that doesn't make any sense. You have to multiply the smaller one by 3 to get the bigger one. Right? So if I said that 6 is 3 times as big as 2, that doesn't mean I would multiply 6 by 3 to get 2. It means I have to multiply the smaller one by 3 to get the bigger one. Right? So that's a little bit tricky. That's one thing to watch out for when they're telling you the relative sizes of things. Don't get too caught up in trying to directly translate the English into math, because that doesn't work very well a lot of the time. What you want to do is get sort of an intuitive picture here about, like, if they say one thing is 3 feet longer than the other, that doesn't mean you add 3 to the big one, even though the 3 is by the big one. It means that you have to add 3 to the small one to get the big one. Same thing here, right? One piece is 3 times as long as the other, means I have to multiply the small piece by 3 to get the big piece. So let's go see what that looks like. So the way I've drawn it here, my small piece is x, and my big piece is 6 minus x. And we said one piece is 3 times as long as the other. So I'm going to have, let's put an equals here. I'm going to have x and 6 minus x on my two sides of the equation, right? Because those are the two pieces. And I'm thinking of 6 minus x as my bigger one. And I know that that's 3 times the length of the smaller one, so I have to multiply the smaller one by 3. Right, and then we solve, and it turns out x is 1.5 feet. Once you get to this point, you are home free, right? This is not a hard equation to solve. You're not going to have trouble doing that. The trick is getting here. So, my tips: draw a picture. For sure, draw a picture. Especially if they're describing some physical thing being divided up in some way, or just used in some way, draw a picture every time. Every time you can. It's so helpful. The other thing is, when you are looking at the problem, look for the is. Is tells you where the equals goes. One side, or the things before the is are one side, the things after the is are generally the other side, with a little bit of an exception. If they're telling you the relative sizes of things, you have to be really careful about how you're adjusting to make them equal, right? One piece is 3 times as long as the other means I must multiply the small piece by 3 to get the big piece. And so whichever piece you're thinking of as the small piece, which will be significantly easier to visualize if you've drawn a picture, right? My x tells me which one I need to multiply by 3, right? I need to multiply the small one by 3 to get the big one, because otherwise that wouldn't make any sense, right? You don't multiply the big one by 3 to make it smaller. All right, last problem. A refrigerator and a dishwasher cost $2,334 together. And when we say together here, that's not like an obvious instruction to do an operation. But when somebody says together, they don't usually mean like multiply them or divide them. What they mean is add them up. So together usually means addition. Not always. You can phrase things weird. But usually if you see together, that generally means addition. So I'm thinking of refrigerator and a dishwasher cost $23.34 together. All right, so let's go see what that looks like. Now, this is one of those cases where I don't have a good, how do I want to say this? There's no reason to use a particular, I'm not liking the way I'm phrasing this. Okay, before I get started, I have two unknown things here. I have a refrigerator and I have a dishwasher and their costs. So I want to define my variables clearly, and I'm going to use variables that go with what they are representing, right? I'm going to use R for the refrigerator and D for the dishwasher. So I'm going to start this problem by saying let R equal cost of refrigerator. So cost of refrige. and let D equal cost of dishwasher. Let me tell you a little story here. I've taught this class a whole bunch of times for many years now. It was one of the first classes I taught when I came to SBCC in 2007. So what is that, 14 years ago now? And this particular thing of writing down what your variables are is one of the number one things that I have struggled to get students to do. Because it seems like busy work, right? It seems trivial. Like, I know R is refrigerator, D is dishwasher, obviously, duh. But that obviously duh part does take mental energy to keep in your brain. And on a test, when everything is flying out of your brain and it's hard to keep track of stuff, you can cheat the amount of mental energy you need by writing some of it down, right? If you write it down, there's no more to remember. I've had a great deal of trouble convincing students of the value of doing this. I will try with you guys. This is incredibly valuable. I would not suggest that you do it if I didn't think it would help you. This is a thing that I do when I'm doing complicated word problems, right? Complicated for me, right? So if I'm doing something that is not just trivial and automatic for me, the first thing I do is write down what everything means so that I don't have to constantly think about it. I can just go refer to it. And so when you are just beginning doing algebra, just write down everything. It's kind of a way to cheat the system, right? Like on a test, what I'm testing is how well does your brain work, sort of. And you can enhance it by writing down some of the things that you need to remember. So don't cheat yourself. So the story goes like, the story I want to tell you was this. This was so important to me, and I tried to emphasize it so much to my students over and over and over again. They just wouldn't do it. That there was a semester where I said, if you do a word problem and you don't clearly define your variables before you use them, like if I see an equation before I see what the variables in the equation are representing, you just get 0, right? I'm just not putting up with it. Like, don't do that. I'm not going to do that in this class, especially for a variety of reasons. But number one is it's mastery graded, and that's pretty harsh, maybe too harsh. It turned out to be a little too harsh in that class. There was a guy who got a C on a test where he should have gotten an A because he did it 3 times. And I didn't feel great about giving that C, and I thought it was maybe a little bit too much. He didn't do it again, but I don't know. Anyway, do this. Save yourself the trouble. It's so much easier if you do. All right, story over. I guess I just wanted an excuse to ramble at you for a little bit. All right, so the expression that I'm looking for here is a refrigerator and a dishwasher cost $23.34 together. So that means I'm going to add the cost together. Right, so my expression is obvious. R plus D, or excuse me, is 23.34. So that's actually an equation. Sorry, I kind of messed that up. Is 23.34. Right, I have an equation already in that first sentence. Yeah, so the cost of the refrigerator and the dishwasher is $23.34. And then we can set this up, right? The refrigerator is $41 less than 4 times the cost of the dishwasher. So that's another equation. The refrigerator is $41 less than 4 times the cost of the dishwasher. So that means that R, the refrigerator, so again, I'm looking for the is 4 times D minus 41. So that gives me another equation. The cost of the refrigerator is $41 less than 4 times the cost of the dishwasher. And we'll learn how to solve these kinds of problems that have 2 equations in them, right? This is not trivial at all to solve. It's not super hard once you learn how, You may even know how, right? You can just substitute into the one into the other, right? R is 4D minus 41. So you take 4D minus 41 and put it in for R and solve. But we don't have to do that right now. Right? I just wanted to make the point that write down your variables, and that often makes the equations much easier to handle, right? Like this one would have been relatively hard to come up with if we didn't have variables for the two appliances. And that, I think, is really what I want to end with. So quick summary. Number one, when you are solving a word problem, look for the is. That will tell you where the equal sign goes. On one side is one expression, on the other side is the other expression. When you are looking at making your expressions, there's a few things to remember, right? These keywords here. There are others. Again, there are others, but this is most of them. The other thing I want to point out is that subtraction is backwards in English. If you say less than, which is the most common, by far the most common way to say this, right? If I say that x is 5 less than y, I'm not doing 5 minus y, I'm doing y minus 5. Whatever it is less than is the thing you start with, and then you subtract off the first bit. So that subtraction is the only one that commonly works that way in English. The others typically go left to right in English. The order you say it in is the order it appears in the equation. Generally, you can get fancy with it, but mostly that's true. When you are given the relative sizes of things, right? One piece is 3 times as long as the other. Don't try to blindly turn that into an equation. Think about what it means. And it generally means that you have to increase whichever is the smaller one or decrease whichever is the bigger one in order to make the two sides equal. So if you're not sure where the plus or the times goes, generally you want to increase the small one or decrease the big one, depending on, like, you can do it either way. So depending on which way you want to write that. I usually think of it as increasing the small one to make things equal. And define your variables. Define your variables clearly. It will save you mental effort for sure. Okay, I think that is all I wanted to say about writing equations. Yeah, so I will go ahead and stop the video and see you guys in the next one.